episteme and techne. Episteme is the Greek word for knowledge, often translated as science, and is personified here by this now headless statue at the Library of Celsus in Ephesus. And it's appropriate that it's carved in marble because it represents a kind of lofty ideal of knowledge for its own sake. Techne, on the other hand, is more practical form of knowledge, craft knowledge, knowledge of how to make things and do things requiring skill. And this red figure vase painting, which is itself a product of craft, shows Hephaestus, the lame metalsmith and minor god of Greek myth, counterpart to the Roman Vulcan. He made himself endlessly useful to Zeus and the other gods, sort of a chief technology officer of Olympus, perhaps more like the IT guy. We see him here in a rather unheroic pose on a donkey carrying his trademark hammer and tongs. So episteme, then, is knowledge, and techne is know-how. And this is a duality that plays out in many ways, even today. We draw a distinction between science and technology. For example, episteme is seen as a matter of discovery of that which already exists in nature, while techne is a process of novel invention that typically results in some manufactured artifact or knowledge of how to create such artifacts. The distinction is sometimes drawn as one of theory versus practice, and philosophers of knowledge, epistemologists, put the duality between propositional and procedural knowledge at the crux of many of their debates. But of more immediate interest to us, as I said, will be the association of episteme with academia and techne with industry. Now sorry, I've skipped around here. The traditions of episteme and techne proceeded continuously from ancient times, as seen in these medieval illuminations. For a time, the church was the guardian of episteme, while the nobility drew on the third estate to meet its technological needs, as for armaments, just as the Olympians had called on Hephaestus. Note how the iconography exhibits a striking parallelism, with the geometer on the left holding a compass and square, and the smithy on the right wielding once again the hammer and tongs. At this point, the practical sciences, such as metallurgy, were still in the realm of the artisan, though soon episteme would begin to illuminate techne with new causal insights and refinements. On the other hand, even mathematics, the purest of sciences, is here symbolized by its tools. So this interdependence of episteme and techne will be a continuing theme. These traditions soon gave rise to more formal institutions, with universities taking over the role of fostering knowledge, reviving the tradition of the Platonic academy, and an artisan class separating out from the new urban middle class, often organizing itself into guilds. In the ideal, at least, universities opened up learning to all, but guilds often functioned to restrict membership and guard trade secrets. Here on the left, we see the Bodleian Library, descendant of the Celsus Library at Ephesus, and on the right, we see the Windsor Guildhall. Both episteme and techne had breakthrough moments, which we now identify as revolutions. The scientific revolution not only radically changed worldviews, but also afforded science itself a new status, associating it with natural laws, mathematical purity, objective rationalism, and rigorous empiricism. Several centuries later, techne had its day with the Industrial Revolution, which of course had enormous economic impact and made prominent a form of mercantilism based on invention and inventiveness. Here on the left, we see Copernicus's conception of the heavens, and on the right, James Watt's steam engine, each a symbol of their respective revolution. Note how the ideas advanced by Copernicus found support through techne in the form of the telescope, while the inventions of Newcomen and Watt would be greatly enhanced with the developing episteme of thermodynamics. Each revolution had pushback in various forms. Galileo was called before the Holy Office for advocating the Copernican view, the Church reasserting its authority. Evolution had myriad knock-on effects on society, not least the rise of factories and urbanization, which in turn contributed to the cultural reaction known as Romanticism. The image of untrammeled nature in literature and art represented a conscious reversion, even going as far as advocating a return to medievalism. The Romantic movement adopted a somewhat muddled attitude to the underlying science, in some cases glorifying it and associating it with nature, but at other times seeing it as slavishly rationalistic and complicit in the perceived evils of industrialization. William Blake embraced an explicit anti-science stance that had earlier roots in Hobbes and Rousseau, and which is seen here in his depiction of Newton as obsessed with his geometric figurings and oblivious to the big picture all around him. The prototype of a nerd, perhaps, though an oddly muscular one. Mary Shelley's Frankenstein, Goethe's Faust also established durable stereotypes of scientists and their failings during this period. Of course, the Industrial Revolution had rather more direct challenges, such as the Luddite movement, which violently attacked its technological base, albeit on economic rather than philosophic grounds. The arch-romantic Lord Byron put down his pen to defend the Luddites and himself denounce automation, making one of his few parliamentary speeches against the imposition of the death penalty for industrial sabotage. The anti-science movement remains with us today in so-called postmodern critiques, in more traditional religious objections to evolution specifically, and in a variety of other forms of public mistrust. Such reactions certainly attended Darwin's theories at their introduction, as the cartoon attests, though they may have been cloaked in objections on scientific or pseudoscientific grounds, as indeed they are today. But just as often today, mistrust of science centers on suspicions of ulterior motives or political agendas, as in the case of global warming. Meanwhile, the excesses of the Industrial Revolution created the conditions that allowed Karl Marx to attack the economic system at its foundation. While that pendulum has certainly swung back from its extreme, the point here is that the institutions of academia and industry each have vulnerabilities in public perception that should be borne in mind in any discussion of their interface. Cliches can be revealing of our attitudes. We think of academia as a curiosity-driven enterprise, while industry is moved along by economic considerations, if not outright cupidity. Academic freedom means following whatever path shows promise, consistently profiting from serendipity, while industry tends to be more narrowly goal-driven, focused, and efficient. On a bad day, academia can be hair-splitting, obsessed with detail, and show-offy, comparing unfavorably with the no-nonsense pragmatism of industry. But on the whole, academia gets good press for holding to higher principles, in particular that truth is beauty and all you need to know. In industry, on the other hand, too often it seems that greed is good. Taking our prejudices to their extremes, we place academia in ethereal ivory towers, disconnected from reality, and industry in the dark satanic mills of William Blake's fevered imagination, as transcribed to the Anglican hymn. And here we see those extremes in artistic expression. On the left is Raphael's famous School of Athens, its airy spaces humming with intellectual horsepower from across the ages, though with just a hint of indolence. On the right is Adolf von Menzel's vision of the industrial age, seeing the forge passed down from Hephaestus as what the artist calls a modern cyclops, all-absorbing and overwhelming to the senses. Each community has a set of ideals at its foundation. The Mertonian norms of science put a premium on cooperation, sharing in a joint and wholly objective quest for episteme, while industry is primarily driven by competition, which in the ideal is healthy and motivational, and in fact legislated. Industry sees its techne as a competitive advantage and tends not to share it freely. Academia is well suited to interdisciplinary work, so often a catalyst of innovation. In industry, cross-disciplinary matrix teamwork is common, though more for efficiency than creativity. And occasionally companies will even set up external joint ventures, albeit at arm's length. Academic institutions freely join in large research consortia, while industry must be very wary lest this be seen as anti-competitive. In spite of the presumed advantages of economies of scale, a recent trend in some pharmaceutical companies is decentralization of R&D juggernauts into smaller, more autonomous teams with better internal communication and less bureaucracy. Each community also has its endemic challenges. Academics must publish without respite